April 9th, 1945. 36,000 feet above Lagerlechfeld, southern Germany. Fähnrich Hans Guido Mutke climbed through crystal-clear skies in his Messerschmitt Me 262 White 9, listening to radio chatter when his instructor's voice cut through. An American P-51 Mustang was closing on a German trainee below. Mutke rolled his jet fighter into a 40-degree dive, twin Junkers Jumo turbines screaming as the airspeed indicator climbed past 950 kilometers per hour, past its mechanical limit of 1 to 100, the needle jamming against the stop. The aircraft began to shake violently. For Mutke, this was more than a training flight. He was flying the world's first operational jet fighter, an aircraft that had changed the rules of aerial warfare. But in that dive, something happened that even he couldn't fully understand. The Me 262 started vibrating so severely that the controls ceased to function. The wings flexed, rivets popped. The airframe groaned under stresses it was never designed to withstand. Then suddenly, the shaking stopped for a few seconds before resuming with even greater violence. His speedometer remained pinned at its maximum reading. The control column felt like dead weight in his hands. Mutke tried everything he'd been taught. He pulled back on the stick. Nothing. The nose continued its downward pitch. At these speeds, aerodynamic forces overwhelmed hydraulic controls. The aircraft was flying itself now, driven by physics more than pilot input. Then he remembered something unique about the Me 262's design. The all-moving tailplane. Unlike conventional aircraft with fixed horizontal stabilizers and movable elevators, the Me 262 allowed the pilot to change the angle of the entire tailplane. He reached for the trim wheel and cranked it desperately. The aircraft shuddered. For a moment, nothing changed. Then gradually, the nose began to rise. Control returned. Mutke throttled back, and both engines flamed out. The turbojets couldn't handle such abrupt throttle changes. Now he was gliding in a powerless jet fighter at extreme altitude. The brief period of smooth flight ended as buffeting resumed, the aircraft shaking violently again as it decelerated through transonic speeds. Years later, engineers would debate whether Mutke had done the impossible, broken the sound barrier 2 years before Chuck Yeager's official supersonic flight. The symptoms matched. Severe buffeting when approaching Mach 1, a brief cessation of vibration when passing through the sound barrier, then resumed buffeting as the aircraft decelerated back below Mach 1. But without calibrated instruments, without controlled test conditions, the claim remained unprovable. Whether he exceeded Mach 1 or not, one thing was certain. He was flying an aircraft that represented humanity's first real glimpse into the jet age, pushing that aircraft to its absolute limits in combat conditions. The story of the Messerschmitt Me 262 is not just about speed. It's about a technological revolution that arrived too late to change the outcome of World War II, but early enough to reshape the future of aviation forever. It's about German pilots who flew aircraft 120 miles per hour faster than anything the Allies could field, yet still found themselves fighting a losing war. It's about Allied bomber crews who watched in horror as silver jets streaked through their formations at speeds they'd never encountered. And it's about the desperation of a collapsing regime that threw its most advanced technology into combat, only to see it overwhelmed by superior numbers, logistics, and the relentless grinding mathematics of industrial warfare. The Me 262 entered combat in the summer of 1944, when Nazi Germany was already losing the war. By then, Allied air superiority was nearly absolute. American B-17 Flying Fortresses and B-24 Liberators flew over German cities in formations numbering more than 1,000 aircraft. Escorted by swarms of P-51 Mustangs and P-47 Thunderbolts, these bomber streams represented an industrial capability Germany could no longer match. German fighter pilots, even the most experienced aces, were being ground down by attrition. Fuel was scarce. Replacement pilots received minimal training. The Luftwaffe was dying. Into this desperate situation came the Me 262, with a top speed of 870 kilometers per hour, 540 miles per hour. It was the fastest combat aircraft in the world. It could outrun any Allied propeller fighter by more than 120 miles per hour. Powered by 2 Junkers Jumo 004 axial flow turbojet engines mounted in nacelles beneath swept wings, the Me 262 looked like nothing else in the sky. Its clean lines, needle nose, and swept wings gave it an appearance of speed even when standing still. The Germans called it Schwalbe, swallow. To Allied pilots, it was simply terrifying. The technical achievement the Me-262 represented cannot be overstated. In 1944, jet engine technology was in its infancy. The entire concept of using continuous combustion instead of reciprocating pistons to generate thrust was barely a decade old. British engineer Frank Whittle had patented the turbojet concept in 1930, but translating theoretical designs into operational engines required solving problems that had never been encountered before. The Jumo 04 turbojets that powered the Me-262 were marvels of engineering, each producing 1,950 pounds of thrust. Inside each engine, a multi-stage axial compressor drew in air and compressed it to 8 times atmospheric pressure. This compressed air then entered combustion chambers arranged in a ring around the engine core where fuel was injected and ignited. The resulting hot exhaust gases, expanding rapidly, drove a turbine that powered the compressor before being expelled through the exhaust nozzle at tremendous velocity. This continuous process generated thrust far more efficiently at high speeds than any propeller could match. But they were also temperamental, unreliable, and required constant maintenance. The engines had an operational lifespan of only 10 to 25 hours before they required replacement or complete overhaul. Think about that. An Me-262 pilot might complete only 5 or 6 combat missions before his engines needed to be swapped out entirely. The high temperatures generated by the combustion process, exceeding 1,500 degrees Fahrenheit in the turbine section, placed extreme demands on materials that Germany, cut off from strategic metals like nickel and cobalt by the Allied blockade, struggled to produce. German metallurgists faced an impossible challenge. Turbine blades needed to withstand extreme temperatures while spinning at speeds exceeding 8,000 revolutions per minute. The centrifugal forces alone would tear apart blades made from ordinary steel. But the special nickel-chromium alloys that could survive these conditions required materials Germany didn't have. Engineers substituted steel alloys containing molybdenum and small amounts of aluminum, creating blades that were barely adequate for the task. They warped, cracked, and failed with alarming frequency. Fuel was another critical vulnerability. The Jumo 04 burned a diesel-like fuel called J2, essentially kerosene. While Germany could produce kerosene more easily than the high-octane aviation gasoline required by piston engines, the jet fuel still needed refining, and Allied bombing had systematically destroyed Germany's synthetic fuel plants. By early 1945, fuel shortages were so severe that some Me-262 bases received only enough fuel for a handful of sorties per week. The engine's slow throttle response created tactical vulnerabilities. In a piston engine fighter, a pilot could jam the throttle forward and get immediate power. The engine would respond within a second, but the Jumo 04 turbojets took 4 to 8 seconds to spool up from idle to full power. Open the throttle too quickly, and the engine would flame out, starving itself of air as too much fuel flooded the combustion chambers. This meant Me-262 pilots had to anticipate their power needs, gradually adjusting throttle settings well before they needed the thrust. In combat, where split-second decisions meant life or death, this delay was potentially fatal. German engineers eventually developed an automatic throttle governor, a mechanical system that prevented pilots from advancing the throttle too rapidly. It helped, but didn't eliminate the problem. The fundamental limitation was physics. Turbojet engines are inherently slower to respond than piston engines, because changing their rotational speed requires accelerating or decelerating massive rotating assemblies. Yet despite these limitations, the Me-262 worked. When its engines functioned properly, when fuel was available, when trained pilots sat in the cockpit, the jet fighter performed like nothing the world had ever seen. It could climb to 30,000 feet in 7 minutes. It could dive at speeds approaching the sound barrier. Its service ceiling, the maximum altitude it could reach, was 37,565 feet, higher than most Allied fighters could effectively operate. And it was armed with devastating firepower. 4 30mm Mk108 cannons mounted in the nose, capable of destroying a heavy bomber with just a few hits. The Mk108 cannon was specifically designed for bomber destruction. Each 30mm shell weighed 330 grams, nearly 12 ounces, and contained 85 grams of high explosive. When these shells detonated inside an aircraft structure, they created devastating damage. A single hit could sever control cables, rupture fuel tanks, or kill crew members. 3 or 4 hits could bring down a B-17 Flying Fortress. Allied bomber crews learned to fear the distinctive thump-thump-thump of 30mm impacts, knowing each hit might be catastrophic. But the Mk-108 had limitations. Its muzzle velocity was relatively low, only 1,120 feet per second, compared to 2,800 feet per second for the 50 caliber machine guns on American fighters. This slow velocity meant the projectiles followed a curved ballistic trajectory, making long-range accuracy difficult. Me-262 pilots had to close to within 600 meters, less than 2,000 feet, to have reasonable hit probability. At the Me-262's typical attack speeds, that distance closed in less than 2 seconds. Pilots had to aim, fire, and break away almost instantaneously. The solution was the R-4M rocket. Some Me-262s carried 24 of these unguided projectiles mounted on wooden racks beneath the wings, 12 per side. Each R-4M rocket was 55 meters in diameter, just over 3 feet long, and carried a high-explosive warhead that could destroy a bomber with a single hit. Fired in salvos from 1,000 meters distance, these rockets created a shotgun pattern through bomber formations. A pilot could ripple fire all 24 rockets in 3 seconds, sending a wall of explosives into the target area, then break away before defensive gunners could respond. General Adolf Galland, one of Germany's most celebrated fighter aces with 104 victories, flew a Me-262 prototype on May 22, 1943. His reaction was immediate and enthusiastic. He described the experience as feeling like angels were pushing. Galland immediately recognized what the jet represented. This wasn't just a faster fighter. It was an entirely new category of aircraft, one that made propeller-driven planes obsolete. He believed the Me-262 could restore German air superiority. He imagined formations of these jets tearing through Allied bomber streams, inflicting casualties so severe that the daylight bombing campaign would have to be abandoned. But Galland's vision encountered obstacles that had nothing to do with engineering. Adolf Hitler, obsessed with retaliation for Allied bombing, ordered that the Me-262 be developed primarily as a fast bomber, a blitz bomber capable of striking back at Allied forces. This directive delayed the fighter variant's development for months. Engineers were forced to modify airframes to carry bombs, compromising performance. Meanwhile, Allied bombers continued to pound German industrial centers, destroying the factories that produced Me-262 components and killing the skilled workers who assembled them. By the time Hitler relented and allowed fighter production to accelerate, it was 1944. Germany had lost the Battle of the Atlantic. The Eastern Front was collapsing. Allied armies were preparing for the Normandy invasion. The industrial capacity required to produce Me-262s in meaningful numbers simply didn't exist anymore. Still, the Germans tried. Messerschmitt factories delivered 1,443 Me-262s before the war ended, but only about 300 ever saw combat. The rest sat on airfields, awaiting engines that never arrived, fuel that couldn't be spared, or pilots who didn't have time to complete their training. Many were destroyed on the ground by Allied bombing raids. The first operational Me-262 jet fighters were deployed to France in April 1944, forming test units that would develop tactics for this revolutionary aircraft. Erprobungskommando 262, later redesignated Kommando Nowotny after the legendary ace Walter Nowotny took command, became the world's first operational jet fighter unit. Nowotny himself was one of the war's highest-scoring aces, with 258 victories, 255 on the Eastern Front and 3 in the Me-262. On October 7, 1944, Kommando Nowotny scored its first confirmed victories. Oberleutnant Franz Schall and Feldwebel Helmut Lenartz intercepted a formation of American B-24 Liberators, each claiming 1 bomber destroyed. It was a glimpse of what the Me-262 could achieve. The jets dove through the bomber formation at speeds the escort fighters couldn't match, fired their cannons, and accelerated away before P-51 Mustangs could intervene. But the unit struggled. The Me-262's temperamental engines failed frequently. Pilots making emergency landings often crashed when both turbojets flamed out simultaneously. Allied fighters learned quickly that they didn't need to catch the Me-262 in flight. They could attack during takeoff and landing, when the jets were slow, vulnerable, and unable to accelerate rapidly. The October 7th mission revealed both the Me-262's potential and its vulnerabilities. Schall's successful attack demonstrated that a skilled pilot in a jet fighter could devastate bomber formations. But the mission also exposed critical weaknesses. Of the 11 Me-262s that took off, several turned back with mechanical problems. Others encountered difficulties maintaining formation at jet speeds. The pilots were still learning how to fly and fight in aircraft that behaved fundamentally differently from anything they'd experienced. Nowotny worked tirelessly to develop effective tactics. Traditional fighter doctrine didn't apply to jets. The Me-262 couldn't dogfight with propeller fighters. Its high speed made tight turning impossible. Any attempt to turn sharply bled energy catastrophically. The jet's weight and wing loading meant it handled sluggishly at low speeds where piston engine fighters excelled. He developed the concept of energy tactics optimized for jet performance. Me-262ers would position themselves 5,000 to 10,000 feet above bomber formations. They would dive at high speed, often exceeding 500 miles per hour, and fire during a single high-speed pass. The entire engagement would last seconds. Then, they would use their superior speed and climb rate to zoom back to altitude, positioning for another attack or escaping from escort fighters. The dive angle was critical, too steep, and the jet accelerated beyond controllable speeds. Too shallow, and escort fighters could intercept. Nowotny calculated that a 30-40 degree dive provided optimal balance, sufficient speed to outrun defenders while maintaining aircraft control. Firing discipline required complete relearning. In a piston engine fighter, pilots could track targets for several seconds, making multiple correction passes. But Me-262s closed so rapidly that pilots had perhaps 2 seconds to aim, fire, and break away. The 30mm cannon's slow rate of fire meant only 90-100 rounds could be delivered in that brief window. Every burst had to count. The psychological challenge was equally significant. These pilots were experienced aces, men with dozens or hundreds of victories in conventional fighters. But the Me-262 demanded different skills. Speed judgment became critical. Pilots had to estimate closure rates at velocities they'd never encountered. They had to aim at deflection angles that seemed impossible. They had to resist every instinct to turn and fight when threatened. Training was complicated by the near-total absence of two-seat trainers. Most Me-262 pilots made their first jet flight in a single-seater, without an instructor, based solely on ground briefings. They learned by doing, often with fatal results. The margin for error was razor-thin. November 8, 1944, became Commando Nowotny's darkest day. Walter Nowotny himself took off to intercept an American bomber formation flying at 30,000 feet, despite orders to remain grounded. General Adolf Galland was visiting the base that morning, along with General Alfred Keller, to inspect the unit and assess its readiness. The previous evening, Galland had stayed late discussing problems with pilots who openly expressed doubts about the Me-262's operational readiness. The morning started badly. Only 2 Me-262s, Charlotte Hessepe and Günther Wegmann at Achmar, initially managed to take off. Erich Büttner suffered a punctured tire during taxiing. Nowotny's turbines refused to start, the engines stubborn and temperamental in the cold morning air. By the time Nowotny finally got airborne, Schall and Wegmann had already engaged the Americans and were returning with battle damage. Nowotny climbed alone toward the bomber stream. He radioed that he'd downed a B-24 Liberator, then claimed a P-51 Mustang destroyed. His voice was calm, professional. Then, one engine failing, a pause, burning. The transmission cut off. Witnesses on the ground saw his aircraft diving, trailing smoke. American Mustangs were in pursuit. Whether they shot him down or he was trying to make an emergency landing when he crashed remains debated. Some historians credit P-51 pilots, First Lieutenant Edward Hayden of the 357th, Fighter Group and Captain Ernest Fiebelkorn of the 20th Fighter Group. Others suggest Lieutenant Robert Stevens of the 364th. Fighter Group delivered the killing shots. Some German accounts claim friendly flak might have hit him. What's certain is that Nowotny's Me-262 crashed east of Hessepe Airfield and he died instantly. He was 23 years old. With 258 victories, he was one of the war's highest-scoring aces, his exploits legendary. His death symbolized the Me-262's fundamental vulnerability. Even the most skilled pilot in the world's most advanced fighter could be killed by mechanical failure at the worst possible moment. Franz Schall also barely survived that morning. After shooting down 2 P-51 Mustangs, both his engines flamed out. Gliding back toward Hessepe, he was intercepted by another Mustang, probably flown by First Lieutenant James Kenny of the 357th Fighter Group, which badly damaged his Me-262. Schwalbe managed to bail out just before his jet exploded. He descended by parachute, watching his aircraft disintegrate. The unit was withdrawn from combat shortly afterward. The losses were unsustainable. The tactics were underdeveloped. The aircraft was still too unreliable for sustained operations. Commando Novotny was disbanded, its surviving pilots and aircraft absorbed into Jägergeschwader 7, which was being formed as the first full-jet fighter wing. The Me-262's combat debut revealed a fundamental problem. Speed alone wasn't enough. The jet's advantages were overwhelming when everything worked perfectly. But combat is never perfect. Engines failed, fuel ran out, pilots made mistakes, and the Allies learned to exploit every vulnerability. Allied fighter pilots developed specific tactics for dealing with jets. They couldn't catch Me-262s in level flight, so they stopped trying. Instead, they patrolled over known Me-262 bases, waiting for the jets to take off or land. The Me-262 required long runways and couldn't accelerate quickly at low speeds. During takeoff, pilots had to nurse the temperamental throttles, gradually increasing power to avoid flameouts. During landing, the jets slowed dramatically, flaps extended, completely vulnerable to attack. The vulnerability began the moment an Me-262 pilot committed to landing. Approaching the runway at roughly 150 miles per hour, with flaps deployed and landing gear extended, the jet lost all its speed advantages. The pilot needed to focus on the runway, on maintaining proper glide slope, on managing engine power carefully, as the turbojets responded sluggishly to throttle inputs. At this moment, a pilot in the world's fastest fighter became as vulnerable as a student on a training flight. Allied intelligence identified every Me-262 base. Photo reconnaissance aircraft photographed the long runways required for jet operations. Signals intelligence tracked radio communications. Captured documents revealed base locations. Allied commanders developed a comprehensive targeting strategy: destroy Me-262s wherever they could be found, on the ground, during takeoff, or during landing approach. On February 25, 1945, Mustangs from the 55th Fighter Group executed this strategy with devastating precision. Intelligence indicated a staffel of Me-262s would be taking off from their base that morning. The Mustangs positioned themselves nearby, waiting. As the jets began their takeoff rolls, accelerating down the runway with engines spooling up slowly, the Mustangs attacked. They destroyed 6 jets before they could get airborne. It was a massacre, a technological and tactical ambush that demonstrated how even the most advanced weapons could be neutralized by well-planned operations. The pilots who survived these attacks described the experience as psychologically devastating. They knew they were flying superior aircraft. They knew that once airborne and at altitude, they could outrun and outfight anything the Allies fielded. But they also knew that every takeoff and landing exposed them to an enemy they couldn't outrun, in conditions where their advantages meant nothing. British pilots in Hawker Tempest developed a tactic called the rat scramble, a name that captured its opportunistic nature. The Tempest was fast at low altitudes, approaching 440 miles per hour at sea level, and extremely maneuverable. When intelligence reported a Me-262 airborne, Tempests on immediate alert would take off, not to intercept the jet in flight, which was impossible, but to race to Me-262 bases and wait for the jets to return. The tactic exploited simple mathematics. An Me-262 pilot, returning from a combat mission, would be low on fuel. The Jumo 004 engines consumed fuel voraciously. The Me-262 carried only enough fuel for 60 to 90 minutes of flight, depending on throttle settings. A pilot who had been cruising at high throttle, engaging targets, performing evasive maneuvers, might have only 10 or 15 minutes of fuel remaining when approaching his base. He couldn't divert to another airfield. He couldn't wait for the Tempest to leave. He had to land, immediately, regardless of threats. As the Me-262 approached with fuel gauges reading nearly empty, traveling slowly with flaps down and incapable of rapid acceleration, Tempest would attack during the landing approach. The jet pilot faced an impossible choice: attempt to land while under attack, or try to evade and run out of fuel. Me-262 pilot Hubert Lang later stated that the Tempest was the jet's most dangerous opponent, extremely fast at low altitudes, highly maneuverable, and heavily armed with 4 20mm cannons that could shred an Me-262's airframe. The rat scramble claimed numerous jets, with British pilots describing it as fishing with dynamite. Effective but unsporting. The Luftwaffe countered these tactics by installing extensive flak alleys, corridors of concentrated anti-aircraft fire along the approach paths to Me-262 bases. These defensive zones featured 88mm and 20mm anti-aircraft guns positioned every few hundred meters, creating a gauntlet that Allied fighters had to penetrate. The guns were carefully positioned to provide overlapping fields of fire, making low-level attacks extremely dangerous. Additionally, formations of Focke-Wulf FW-190D Dora fighters were assigned to provide top cover during Me-262 takeoffs and landings. These piston-engine fighters, painted with bright red undersides and white stripes so German anti-aircraft gunners wouldn't shoot them down by mistake, became known as the Papagei-Staffel, the Parrot Squadron. Their job was brutal and straightforward. Dogfight with Allied fighters, while Me-262s accelerated to safety or slowed for landing. The FW-190D pilots knew they were flying inferior aircraft. A Mustang or Tempest on the deck could match or exceed their performance. But they had to engage anyway, drawing Allied fighters into turning fights that gave Me-262s those critical seconds to get airborne or touch down safely. It was sacrificial duty, with FW-190D pilots suffering heavy losses to protect jets they would never fly themselves. The defensive system worked, partially. Flak shot down numerous Allied fighters. The FW-190Ds scored victories. Me-262 operations continued despite the Allied pressure, but the losses were steady and cumulative. Every base that became too dangerous to operate from meant jets relocating to alternate fields. Every relocation meant disrupted logistics, interrupted maintenance, and reduced operational tempo. Despite these defensive measures, losses mounted relentlessly. Allied medium bombers, B-26 Marauders and A-20 Havocs, targeted Me-262 airfields with precision attacks, cratering runways and destroying support facilities. P-47 Thunderbolts and P-51 Mustangs strafed parked jets, which were sitting ducks on the ground. Intelligence identified every known Me-262 base, and Allied air commanders prioritized their destruction with methodical thoroughness. By April 1945, some Me-262 units were operating from sections of Autobahn, Germany's superhighway system, using straight stretches as improvised runways. Trees alongside the highway provided concealment. Ground crews worked from the woods, but operating from highways meant minimal facilities, no permanent maintenance capabilities, and constant vulnerability to roving Allied fighters who patrolled likely highway sections looking for targets of opportunity. Yet when Me-262s reached altitude and engaged enemy formations on their own terms, they were devastating. On March 18, 1945, 37 Me-262s from Jagdgeschwader 7 intercepted a massive Allied raid, 1,021 bombers, escorted by 632 fighters. The jets shot down 12 bombers and 1 fighter, losing only 3 Me-262s. It was a 4-to-1 kill ratio, exactly what Germany needed to make an impact. But those 12 bombers represented only 1% of the attacking force. The mathematics of attrition were pitiless. Germany simply couldn't produce enough jets, train enough pilots, or deliver enough fuel to make a strategic difference. By early 1945, specialized Me-262 units were operating across Germany. Jagdgeschwader 7, the world's first operational jet fighter wing, flew from bases near Berlin. Kampfgeschwader 54 used Me-262s as fighter bombers. Though losses were catastrophic, 12 jets destroyed in 2 weeks for minimal results. And then there was Jagdverband 44. In February 1945, Adolf Galland formed Jagdverband 44 after being relieved of his position as General der Jagdflieger. Hermann Göring, furious at Galland's constant criticism of Luftwaffe strategy, essentially dared him to prove the Me-262's potential. Göring suspected the mission might kill Galland, which suited him fine. But Galland assembled a remarkable unit, a squadron of Germany's most experienced aces. He recruited Johannes Steinhoff, Gerhard Barkhorn, Heinz Baer, and other legendary pilots. It became known as the Squadron of Experts. Operating from Munich-Riem and other southern German airfields, Jagdverband 44 flew combat missions until the final days of the war. On April 26, 1945, Galland led 12 Me-262s against American B-26 Marauders attacking targets in Bavaria. The jets tore through the bomber formation in multiple passes. Galland's aircraft shot down 2 Marauders. Then P-47 Thunderbolts dove into the fight. Lieutenant James Finnegan, leading the escort, spotted Galland's Me-262 and executed a split S dive, positioning himself perfectly. He fired a 3-second burst, Cannon shells struck Gallen's right engine and wing root. Metal fragments tore into the cockpit. Shrapnel embedded itself in Gallen's right knee. Both engines were hit. The controls stopped responding. Gallen nursed his crippled jet toward Munich-Riem airfield, trailing smoke. He managed to wobble his wings, the traditional signal that he was coming in damaged, and cut both engines just before reaching the runway. The Me-262 bumped to a halt with a flat tire. Gallen threw open the canopy and climbed out awkwardly as Allied fighter bombers began strafing the airfield. His flying career was over. It was effectively the last combat mission of one of Germany's greatest aces. Jagdverband 44 continued operating for a few more days. On May 4, 1945, with American forces closing in, the unit destroyed its remaining Me-262s by placing hand grenades in the engine intakes. Surviving pilots surrendered. The jet age's first combat unit ceased to exist. But what made the Me-262 so fast? The answer lies in the fundamental physics of jet propulsion. Propeller-driven aircraft are limited by propeller efficiency. As blade tips approach the speed of sound, they lose effectiveness. No propeller can efficiently generate thrust much beyond 400 miles per hour. But jet engines work differently. They accelerate air rearward to generate thrust, and this process becomes more efficient at high speeds. The Me-262's Jumo 004 turbojets ingested air through intakes, compressed it, mixed it with fuel, ignited the mixture, and expelled hot exhaust gases at tremendous velocity. The resulting thrust pushed the aircraft forward. The Me-262 could sustain 540 miles per hour in level flight, about 870 kilometers per hour. In dives, it could go much faster. Pilots routinely reported speeds exceeding 600 miles per hour, and some, like Hans Guido Mutke, claimed to have reached transonic speeds approaching or even exceeding Mach 1, the speed of sound. Mutke's April 9, 1945 dive became one of aviation's most controversial claims. During his steep descent from 36,000 feet, his airspeed indicator maxed out at 1,100 kilometers per hour, 684 miles per hour. The speed of sound at that altitude was approximately 1,062 kilometers per hour, about 660 miles per hour. Mutke reported violent buffeting, loss of control, then a brief period where the shaking stopped and control returned before resuming again. These symptoms match what later supersonic pilots experienced when breaking the sound barrier. But did Mutke actually exceed Mach 1? Experts remain divided. Messerschmitt's own testing established that the Me-262 lost controllability in dives at Mach 0.86. The nose would pitch down uncontrollably, and the pilot couldn't prevent the aircraft from entering a fatal steepening dive. Yet Mutke survived. He later credited his survival to adjusting the Me-262's all-moving tailplane, changing the angle of incidence of the entire horizontal stabilizer, a feature later incorporated into the Bell X-1 rocket plane that officially broke the sound barrier in 1947. A 1999 computer analysis conducted at Munich Technical University concluded that the Me-262 was theoretically capable of exceeding Mach 1 in a steep dive with full engine power. The combination of gravity and thrust might have provided sufficient force to overcome the massive drag increase at transonic speeds. But without instrumentation capable of recording the exact speed, and given the chaotic nature of Mutke's combat flight, the claim cannot be definitively proven or disproven. What is certain is that Mutke experienced transonic effects, the buffeting, control problems and airspeed indicator anomalies that occur as shock waves form over the aircraft. Whether the aircraft as a whole exceeded the speed of sound, or whether only airflow over certain sections did so, remains a matter of debate. Chuck Yeager's 1947 flight in the Bell X-1 remains, officially recognized as the first controlled supersonic flight because it was conducted under carefully monitored test conditions with calibrated instruments. But the Me-262's ability to approach these speeds demonstrated something profound. The jet age had arrived. Within a few years, jet fighters would routinely exceed Mach 1. By the 1950s, Mach 2 became achievable. The Me-262 was the ancestor of every modern jet fighter. The aircraft's combat tactics were as revolutionary as its technology. German pilots couldn't dogfight with Allied propeller fighters. The Me-262's high speed made tight turning impossible. Any attempt to turn sharply bled energy rapidly. The jet's weight and wing loading meant it handled sluggishly at low speeds, and the engine's slow throttle response meant pilots couldn't rapidly adjust power during maneuvering. If a Me-262 pilot got drawn into a low-speed turning fight with a Mustang or Spitfire, he was at a severe disadvantage. Instead, Me-262 pilots developed boom and zoom tactics. They positioned themselves above Allied bomber formations, dove at high speed, fired their cannons or rockets in a single pass, then climbed away using their superior speed and rate of climb. The entire engagement lasted seconds. Allied fighters couldn't intercept because by the time they saw the jets, the Me-262s were already accelerating out of range. Franz Schall, the Me-262's top ace, with 17 jet victories including 6 four-engine bombers and 10 P-51 Mustangs, perfected this approach through relentless practice and cold calculation. Schall was a natural pilot with exceptional spatial awareness and split-second decision-making abilities. He understood that the Me-262's speed was both its greatest strength and its primary limitation. His typical attack profile began at 36,000 feet, positioning his Me-262 above and behind approaching bomber formations. He would study the enemy formation, identifying weak points, typically the rear or flanking elements where defensive fire was less concentrated. Then he would roll inverted and dive, building speed rapidly. At 500 miles per hour and increasing, he would close to within 600 meters of the target, roughly 2,000 feet. At this range, with a closing speed exceeding 700 miles per hour, he had approximately 2 seconds before collision became inevitable. His finger would squeeze the trigger. All 4 30mm Mk108 cannons would fire in a concentrated burst. The gun's combined rate of fire meant roughly 90 rounds would be released in those 2 seconds. The low muzzle velocity meant he had to lead the target significantly, aiming not where the bomber was, but where it would be in the fraction of a second before impact. Then, immediately, he would pull back hard on the stick, using the Me-262's speed to zoom climb away from the bomber formation. The jet's excellent energy retention meant he could convert speed into altitude rapidly, positioning himself for another attack or escaping from escort fighters who couldn't match his climb. Rate. Schall described bomber defense fire as a wall of tracers, B-17 and B-24 formations, flew in tight boxes specifically designed for mutual defensive support. Each bomber carried 10 50 caliber machine guns. A formation of 30 bombers meant 300 machine guns, all trained on approaching fighters. The volume of fire was staggering. Tracers crisscrossed the sky in streams of orange and red. For every tracer visible, 4 additional bullets flew unseen, but the Me-262's speed reduced exposure time dramatically. A conventional fighter attacking at 300 miles per hour gave gunners several seconds to track and fire. The Me-262 at 500 plus miles per hour reduced that window to less than 2 seconds. Many gunners couldn't even swing their weapons fast enough to track the jet. Schall's technique required absolute precision. He couldn't simply spray bullets and hope for hits. With only 100 rounds per gun in the 2 outer cannons and 80 rounds in the 2 inner cannons, a total of 360 rounds carried, he had ammunition for perhaps 4 or 5 attacks before returning to base. Every burst had to count. This wasn't spray and pray combat. It was surgical strikes requiring perfect timing. His victories reflected this mastery. On October 7, 1944, he downed his first B-24 Liberator. On March 18, 1945, during a massive Allied raid on Berlin, he claimed 2 more bombers. On March 23, he shot down a P-51 Mustang. The next day, another P-51 in the Cottbus-Bautzen-Dresden area. On March 24, leading his Staffel from Parchim Airfield, he engaged a massive formation of 1,714 bombers, escorted by 1,300 fighters. That March 24th engagement showed both the Me-262's potential and the overwhelming odds German pilots faced. Approximately 15 Me-262s, most armed with R-4M rockets, attacked the bomber streams south of Berlin. They claimed multiple bombers destroyed, but even if every jet shot down 4 bombers, an exceptional kill ratio, it represented less than 1% of the attacking force. The mathematics were brutal and inescapable. Schall continued scoring victories through early April 1945. On April 4, he claimed another P-51. On April 9th, during a Royal Air Force raid on Kiel, he engaged British bombers. His final victory came on April 10, 1945. Another P-51 Mustang. Then, during what should have been a routine landing at Parchim Air Base, disaster struck. Schall's Me-262 touched down, but Allied bombing had cratered sections of the runway. German ground crews had filled the craters with dirt and marked them with white boundaries. Pilots were supposed to avoid these patched sections, but Schall's aircraft, traveling at high speed, drifted slightly off the safe path. The left landing gear wheel dropped into a partially collapsed bomb crater. The gear collapsed immediately. The Me-262 cartwheeled, one wing striking the ground. Fuel tanks ruptured. The aircraft exploded in a massive fireball. Scholl died instantly. He was 26 years old, with 137 total victories in 550 combat missions. He had survived years of combat on the Eastern Front, where he had claimed 61 Il-2 Sturmovik ground attack aircraft. He had mastered the Me-262's demanding flight characteristics, but a bomb crater and a moment's inattention killed him just as surely as enemy fire would have. His death exemplified the impossible conditions under which Me-262 units operated. It wasn't enough to be an exceptional pilot. You also needed functional runways, which Allied bombing systematically destroyed. You needed reliable engines, which material shortages made impossible. You needed adequate fuel, which was increasingly unavailable. You needed time to rest between missions, which the Reich's desperate situation didn't allow. The best pilots in the world, flying the most advanced aircraft, were being ground down by systemic failures they couldn't overcome through skill alone. The R-4M rockets provided an alternative. Fired from beyond the range of bomber defensive guns, these unguided projectiles had a 55mm warhead capable of destroying a bomber with a single hit. Me-262s could ripple-fire all 24 rockets in seconds, sending a wall of explosives through a bomber formation. The tactic, nicknamed the Luftwaffe's Wolfpack, became standard procedure for attacking bomber streams, but the Me-262's greatest enemy wasn't Allied fighters. It was Germany's collapsing infrastructure. By 1945, fuel shortages were so severe that Me-262s were sometimes towed to the runway by horses or oxen to conserve fuel. Many airframes sat idle, waiting for engines that never arrived because factories had been bombed and workers killed. The specialized jet fuel, a form of kerosene called J2, was in short supply. Training new pilots became impossible. By the final months of the war, many Me-262 pilots made their first jet flight in a single-seater, without an instructor, because two-seat trainer variants were almost non-existent. Allied air supremacy was absolute. Even when Me-262s managed to get airborne, they faced overwhelming numbers. A single staffel of 12 jets might encounter formations of 1,000 bombers with 500 fighters. The mathematics were brutal. Even with a 4-to-1 kill ratio, even if every Me-262 pilot shot down 4 Allied aircraft before being killed himself, Germany was still losing. The Allies could replace losses. Germany couldn't. On April 10, 1945, Franz Schall scored his final victory, a P-51 Mustang. Then he attempted an emergency landing at Parchim Air Base. His Me-262 rolled into a bomb crater and exploded. Scholl died instantly. He had claimed 137 total victories in 550 combat missions, 14 of them while flying the Me-262. He was one of the jet's most successful pilots. His death symbolized the aircraft's ultimate failure. Superior technology overwhelmed by superior numbers and resources. Other Me-262 aces included Oberleutnant Kurt Welter, who claimed 25 Mosquito night bombers destroyed, mostly achieved without radar by using visual tracking. Oberstleutnant Heinz Baer with 16 victories in the Me-262 out of his 240 total, and Georg Peter Eder with 12 jet victories including 9 P-51s. These pilots proved the Me-262 was a formidable fighter when flown properly. But individual excellence couldn't overcome systemic collapse. On May 8, 1945, the last Luftwaffe victory of World War II was claimed by Oberleutnant Fritz Stehler of Jagdgeschwader 7. Flying in Me-262 in the Ore Mountains, he attacked a formation of Soviet aircraft and claimed a Yakovlev Yak-9 destroyed, though the aircraft was probably an Airacobra. Soviet records confirmed they lost 2 Airacobras that day. Stahel's victory came hours before Germany's unconditional surrender. The jet age's first chapter ended in defeat. Yet the Me-262's legacy extended far beyond Germany's military collapse. American forces captured dozens of Me-262s, along with German engineers and test pilots. These aircraft were shipped to Wright Field in Ohio for extensive testing. British forces conducted similar evaluations at Farnborough. Both nations immediately recognized the jet's importance. The lessons learned from the Me-262 directly influenced post-war jet fighter development. The North American F-86 Sabre, which dominated Korean war skies, owed much to Me-262 aerodynamics. The Soviet MiG-15 incorporated German jet engine technology captured at war's end. Nearly every jet fighter designed in the late 1940s and early 1950s showed Me-262 influence: swept wings, nose-mounted armament, underslung engine nacelles. The Me-262 established the template. More fundamentally, the Me-262 demonstrated that jet propulsion was the future of military aviation. Piston-engine fighters, no matter how refined, couldn't compete with jets. Within 5 years of war's end, major air forces were transitioning entirely to jet-powered aircraft. Within 10 years, propeller fighters were obsolete for frontline combat roles. The transformation was total and irreversible. But the Me-262 also illustrated a harsh truth about technological warfare. Innovation alone doesn't win wars. Germany fielded the world's first operational jet fighter, the world's first cruise missile in the V-1, the world's first ballistic missile in the V-2, and the world's first rocket-powered interceptor in the Me-163 Comet. None of these wonder weapons changed the war's outcome. They arrived too late, in too few numbers, with insufficient infrastructure to sustain them. The Allies won World War II not through superior individual weapons, but through superior production, logistics, and resources. America built 15,000 P-51 Mustangs between 1942 and 1945. Germany managed 1,443 Me-262s. America had the fuel to fly every one of those Mustangs. Germany had to tow its jets with horses. America trained replacement pilots faster than they could be killed. Germany threw inexperienced pilots into combat with minimal instruction. The material advantages were overwhelming. General Karl Spaatz, commanding the United States Strategic Air Forces in Europe, expressed fear in September 1944 that if Me-262s appeared in large numbers, they could inflict losses severe enough to halt the daylight bombing campaign. It never happened. Not because the Me-262 wasn't capable, it was, but because Germany lacked the industrial capacity, fuel supply, pilot training infrastructure, and airbase network to field jets in meaningful numbers. Albert Speer, Hitler's armaments minister, later wrote that the Me-262 was Germany's most advanced weapon, but arrived too late to affect the war's outcome. Had it been deployed in 1943, as Galland urged, when Germany still controlled adequate fuel supplies and possessed experienced pilots, the story might have been different. Formations of 200 or 300 Me-262s attacking Allied bomber streams could have inflicted catastrophic losses. Air superiority over France in June 1944 might have made the Normandy invasion impossible or far more costly, but that's speculation. The historical reality is that the Me-262 entered combat in mid-1944 when the war was already lost. It represented a technological glimpse into the future, not a weapon that could reverse Germany's strategic collapse. For the pilots who flew it, the Me-262 was both thrilling and frustrating. It was the fastest, most powerful fighter they'd ever experienced. But it was also temperamental, mechanically unreliable, and desperately short-handed. They flew knowing that engine failure might occur at any moment, that fuel shortages could strand them on the ground, that every takeoff and landing exposed them to devastating fighter sweeps. They fought knowing the war was lost, that their technological superiority couldn't overcome the Reich's industrial and logistical collapse. Hans Guido Mutke survived the war. After his controversial dive on April 9th, he landed his damaged Me-262 to find rivets missing and wings distorted from the extreme stresses. On April 25, 1945, he flew his jet into neutral Switzerland, claiming he'd lost his way during a mission to engage B-26 marauders. Others believed he was defecting. The Swiss impounded his Me-262 and held it until 1957, when they returned it to Germany. It's now displayed at the Deutsches Museum in Munich, the most authentic surviving Me-262 in the world. Mutke later became a gynecologist and aviation medicine specialist. He never stopped claiming he'd broken the sound barrier. He died in 2004 during heart surgery at age 83, still convinced he'd achieved something extraordinary. In those final desperate days of the Third Reich, Galland surrendered to American forces in May 1945 after his release from captivity in 1947. He lectured on fighter tactics for the RAF, then worked as a consultant for the Argentine Air Force. He later returned to Germany, managed his own business, and became friends with former enemies, including RAF aces Robert Stanford Tuck and Douglas Bader. He died in 1996 at age 83, having lived long enough to see jet fighters become so advanced that his Me-262 looked primitive by comparison. but he never wavered in his belief that the jet, had it arrived earlier, could have changed the war. The Me 262 serves as a technological monument, a reminder that wars are won by industrial systems, not individual weapons. Germany produced brilliant engineers who designed revolutionary aircraft, but Germany lacked the oil reserves, industrial capacity, and strategic depth to exploit those designs. The Reich ran out of fuel, factories, trained workers, and time. No amount of technological sophistication could overcome those fundamental deficiencies. Today, 9 Me 262s survive in museums worldwide. Several are displayed in the United States, including one at the Smithsonian's National Air and Space Museum. Replicas built in the 1990s and 2000s using original plans demonstrate that the design was fundamentally sound. When equipped with modern engines, these replicas perform impressively. But the originals, with their fragile Jumo 04 turbojets and wartime construction quality, were far more temperamental than history sometimes remembers. The Me 262 represented a transition point in military aviation. It was the last fighter developed in the piston engine era that used jet propulsion. Its design incorporated compromises necessitated by incomplete understanding of high-speed aerodynamics. The swept wings, for instance, were added primarily to balance the aircraft's center of gravity after the heavy engines were positioned in underwing nacelles. The sweep turned out to benefit high-speed performance, but that was partially accidental. Later, jet fighters would feature true swept wings designed specifically for transonic and supersonic flight. Yet despite these limitations, the Me 262 was genuinely revolutionary. It proved that jet fighters were practical. It demonstrated that air-to-air rockets could be effective bomber destroyers. It showed that with proper tactics, high-speed fighters could devastate slower opponents. And it established jet propulsion as the dominant paradigm for military aviation. The pilots who fought in Me 262s experienced warfare's bleeding edge. They flew aircraft decades ahead of their time, yet they did so within a military system collapsing around them. Their experiences bridged two eras, the age of propeller-driven combat and the jet age that followed. When they climbed into those cockpits, with twin turbojets spooling up behind them and the promise of unmatched speed ahead, they represented both the future of aviation and the final, desperate gamble of a dying regime. The Allied bomber crews who encountered Me 262s in combat never forgot the experience. Seeing silver jets streak through bomber formations at 540 miles per hour was terrifying. The jets appeared suddenly, fired devastating salvos, and disappeared before defensive guns could track them. Tail gunners reported watching Me 262s approach from behind, then realizing with horror that their gun sights couldn't adjust fast enough. The jets were simply too fast. But those bomber crews also knew they had an advantage the Germans couldn't match: numbers. For every Me 262 that attacked, there were 10 Mustangs and Thunderbolts providing escort. For every German jet destroyed, Allied factories built 5 Mustangs. The material balance was so lopsided that even miraculous technology couldn't shift it. This is the paradox the Me 262 embodies. It was the most advanced fighter of World War II, yet it had virtually no strategic impact. It killed hundreds of Allied airmen, destroyed hundreds of Allied aircraft, yet never came close to threatening Allied air supremacy. It represented the cutting edge of aviation technology, yet flew for a nation whose fuel supplies, trained pilots, and industrial capacity were all in terminal decline. In the final analysis, the Me 262 was a magnificent aircraft flying for a defeated cause. Its pilots were brave, skilled, and desperate. Its designers were brilliant. Its performance was astonishing. But none of that mattered. Wars are won by industrial capacity, resource availability, and strategic depth. Germany lacked all three. The Me 262 couldn't overcome those fundamental deficiencies. It could only demonstrate with shattering clarity what might have been possible had it arrived 2 years earlier, when Germany still possessed the means to mass produce and properly support such revolutionary technology. The jet age that the Me 262 inaugurated would transform military aviation completely. Within 20 years, fighters would routinely exceed Mach 2. Within 40 years, stealth technology would make aircraft invisible to radar. Within 60 years, fighters would carry guided missiles with ranges exceeding 20 miles, eliminating the need for close-range dogfighting entirely. The propeller-driven combat that dominated World War II became as obsolete as cavalry charges. But in 1945, as Me 262s flew their final missions over a crumbling Reich, none of that future was visible. There was only the present, jets screaming through bomber formations, Allied fighters hunting them at their bases, fuel running out, pilots dying, and Germany collapsing. The revolution the Me-262 represented arrived too late to save its creators, but it arrived just in time to shape the future. The silver jets with their twin turbines and swept wings became symbols of technological possibility. They demonstrated that human ingenuity could break through barriers previously thought insurmountable. If aircraft could fly at 540 miles per hour, why not 600? Why not 700? Why not faster than sound itself? The questions the Me-262 posed drove aviation development for decades. Afterward, every modern jet, fighter, from the F-22 Raptor to the Eurofighter, Typhoon to the Russian Su-57, owes a conceptual debt to the Me-262. They all use jet propulsion. They all mount weapons in or under the fuselage. They all prioritize speed and energy retention over maneuverability. They all represent refinements of ideas first proven in combat by German pilots flying Messerschmitt Me 262s over the ruins of the Third Reich. But the legacy extends beyond specific technical features. The Me-262 established a fundamental principle. Technological superiority doesn't guarantee military success. An army needs not just advanced weapons, but the industrial infrastructure to produce them in quantity, the logistical networks to sustain them, the fuel supplies to operate them, and the training systems to use them effectively. Remove any element from this chain, and the entire system collapses. Germany in 1945 had the advanced weapons: Me-262 jets, Tiger tanks, Type 21 submarines, V-2 ballistic missiles. What Germany lacked was the industrial ecosystem to make those weapons strategically relevant. The Me-262 demonstrated this truth with brutal clarity. You can design the world's fastest fighter, but if you can't produce engines reliably, if you can't train pilots adequately, if you can't fuel the aircraft consistently, then the design is militarily meaningless. This lesson shaped post-war military doctrine. The United States, emerging from World War II as the dominant industrial power, understood that future conflicts would be won not by individual wonder weapons, but by comprehensive military-industrial systems capable of sustained operations. This insight drove American military planning throughout the Cold War and beyond. The men who flew those aircraft knew they were witnessing something extraordinary, even as they fought a losing war. They knew the piston engine era was ending. They knew they were piloting the future. What they couldn't know was how completely that future would transform aviation. Heinz Baer, who scored 16 victories in the Me-262 out of his 240 total kills, later reflected on the experience. He described flying the jet as entering a different realm of aviation: the smooth acceleration, the sustained high-speed flight, the complete absence of propeller vibration, all contributed to a sensation that traditional pilots had never experienced. He also noted the psychological burden of flying such an advanced aircraft for a losing cause. Every mission was potentially futile, yet every pilot flew knowing they were part of aviation history. Gerhard Barkhorn, another JV-44 pilot with 301 total victories, though none in the Me-262, he was still transitioning when the war ended, described the unit's atmosphere as surreal. Here were Germany's most experienced fighter aces, men who had survived years of brutal aerial combat, flying the most advanced fighters in the world, yet they all knew the war was lost. They fought not for victory, which was impossible, but for professional pride and the hope that their experience might somehow matter in whatever came after Germany's defeat. The technological knowledge didn't die with the Third Reich. Operation Lusty, Luftwaffe secret technology, saw Allied intelligence teams systematically capture German aircraft, engineers and documentation. Dozens of Me-262s were shipped to the United States and Britain for testing. German aeronautical engineers were recruited to work for Allied aviation programs. The expertise that created the Me-262 became part of Western technological development. Some of this technology transfer was voluntary. German engineers, facing a devastated homeland with no industrial capacity, eagerly accepted offers to work for the victorious powers. Others were more coerced, finding themselves in Allied custody with their expertise more valuable than their freedom. Either way, the knowledge flowed westward. Today, we fly in airliners powered by turbofan engines that are direct descendants of the Jumo 004. The principles are identical: compress air, burn fuel, extract energy, generate thrust. Modern engines are vastly more reliable, efficient, and powerful, but they work exactly as those primitive German turbojets did in 1944. Commercial aviation, which carries billions of passengers annually, operates on technology principles first proven in Combat over Germany. We fight with jet fighters that trace their lineage to the Me-262. The F-86, Sabre that dominated Korean skies, owed much to Me-262 aerodynamics. The MiG-15 that opposed it used German turbojet technology captured by Soviet forces. Nearly every jet fighter developed in the decade after World War II showed direct Me-262 influence. We've traveled from 540 miles per hour to spacecraft capable of orbital velocity, 17,500 miles per hour. We've gone from jets that could barely break the sound barrier in controlled dives to fighters that routinely exceed Mach 2. We've developed stealth technology, guided missiles with 100-mile ranges, and radar systems that can track hundreds of targets simultaneously. The journey began in the skies over Germany in 1944, when desperate men in revolutionary aircraft tried to turn the tide of an already lost war. They failed, but in failing, they succeeded in proving that the future of flight wasn't propellers, it was jets. And that legacy, more than any tactical victory or strategic impact, is the Me-262's true contribution to history. It didn't win the war, but it defined what came after. The final irony is this: the Me-262 was obsolete within 5 years of its combat debut. By 1950, first-generation jet fighters like the F-86 and MiG-15 surpassed its performance in every metric. By 1960, second-generation jets made it look primitive. Today, it would be helplessly outmatched by even a basic trainer jet. Yet the Me-262 remains profoundly important precisely because it was first. It proved concepts that seemed impossible. It demonstrated that jet propulsion could work in combat conditions. It showed that swept wings improved transonic performance. It established that conventional dogfighting tactics didn't work at jet speeds. Every lesson, both successful and failed, informed the designs that followed. The 9 surviving Me-262s in museums worldwide are more than historical artifacts. They're technological monuments marking the transition between eras. Stand before one, and you're looking at the aircraft that ended the age of propeller-driven combat and began the jet age. You're seeing the machine that inspired every jet fighter that followed. You're confronting a weapon that represented both the apex of German engineering and the futility of technological excellence without industrial support. For the pilots who flew them, the Me-262 represented both their greatest achievement and their deepest frustration. They had mastered the most demanding aircraft of their era, proven themselves in combat against overwhelming odds, yet nothing they accomplished could change the war's outcome. They were superb craftsmen, wielding magnificent tools in a workshop that was burning down around them. Hans Guido Mutke lived until 2004, spending decades as a physician and aviation medicine specialist. He never stopped claiming he'd broken the sound barrier on April 9, 1945. The debate continued until his death, and continues still. But whether his Me-262 exceeded Mach 1 or not, the fact that the question can even be seriously debated says everything about the aircraft's revolutionary nature. That a wartime jet fighter, designed with slide rules and incomplete understanding of transonic aerodynamics, could approach the speed of sound demonstrates just how advanced the Me-262 truly was. Adolf Galland died in 1996, having witnessed the complete transformation of aerial combat from the propeller fighters he flew in Spain in the 1930s to stealth jets and guided missiles. He maintained friendships with former Allied pilots, including men who had shot at him during the war. He consulted for air forces around the world, but he never wavered in his belief that the Me-262, deployed earlier in greater numbers, could have fundamentally altered the air war over Europe. Whether he was right remains one of history's great counterfactuals. The truth is probably more nuanced. Even 500 Me-262s deployed in early 1943 wouldn't have won the war for Germany. The industrial imbalance was too extreme. But they might have delayed Allied victory, inflicted far heavier casualties on bombing campaigns, possibly even forced modification of strategic planning. The jets represented a capability the Allies had no answer for, until they developed their own jets, which wouldn't have happened as quickly without the German example to copy. What's certain is that the Me-262 changed aviation forever. It ended the propeller age. It began the jet age. It demonstrated that fundamental technological transformations could occur even in the midst of total war. And it established that future air combat would be dominated not by the most maneuverable fighters, but by the fastest, by aircraft that could dictate engagement terms through superior energy management. Every pilot who climbs into a modern fighter jet, every passenger who flies on a commercial airliner, every person whose life has been touched by jet aviation, all of them are living in the world the Me-262 helped create. The silver jets that streaked across German skies in 1945 were harbingers of a revolution that would remake not just military aviation, but human transportation itself. They flew for only a few months. They achieved relatively little strategic impact, but they proved what was possible. And in warfare, in technology, in human endeavor, proving something is possible is often more important than any immediate tactical success. The Me-262 proved that jet fighters could work. Everything that followed built on that proof. The documentary evidence is clear. The Me-262 was a magnificent technological achievement deployed in impossible circumstances. It represented the cutting edge of human engineering capability applied to warfare. It showcased extraordinary pilot skill in desperate combat conditions. And it ultimately demonstrated that wars are won not by individual superior weapons, but by comprehensive industrial and logistical systems that can sustain operations over time. This is the final lesson the Me-262 teaches. Technology matters, but systems matter more. Innovation is valuable, but production is essential. Quality is important, but quantity cannot be ignored. Germany had quality. The Allies had quantity. The Allies won. Yet the jets remain in our collective memory as symbols of technological daring. They represent the moment when aviation broke free from its propeller-driven limitations and entered a new age. They embody both the promise of innovation and the harsh reality of industrial warfare. They stand as testament to human ingenuity and as warning about technological hubris. The Me-262 was the right aircraft at the wrong time, flying for the wrong cause, in circumstances that guaranteed its failure. But it flew nonetheless, and in flying changed aviation forever. That's its legacy. Not victory, but transformation. Not success, but revolution. Not the end of a war, but the beginning of a new age.